Hello everyone, welcome to BYJU'S exam prep. Welcome to your next class in a very special series that we are continuing special 26 for your upcoming gate examination. So कैसे हो आप लोग? I hope everybody is doing very well guys, and tell me who has joined the session. So today's session is going to be an important session for the electrical students because we are going to discuss a very important subject, power system, and the very important topic which is the transmission line parameter. Now, as you know that in this particular series we have chosen the 26 topic from electrical and EC branch, which from where you can be sure that 85 to 90% questions will come from this topic. So different faculties are taking different topics. For example, Rakesh sir and Sanjay sir, Saket sir are taking different subjects. I am taking the core electrical subjects, in which last week I have taken the classes on machine. So we have discussed 3 topics in machine. I hope you have seen that particular class. If not, you can watch it on our channel. Now in today's class we are going to discuss the question based on the transmission line parameter, and that you can easily expect the question that will come from this particular topic. So the particular concept, the inductance calculation, ABCD parameter, all of this we are going to discuss through questions. Now before starting a session, first of all tell me who else are online. Also share the session among your friends so that more and more students can join the session and be a part of this initiative. Now before starting, let me introduce myself. My name is Shan Mudgal. I have a 7+ year of teaching experience. I'm the gold medalist from NIT Allahabad, 7 times gate qualified, and these are my area of expertise. And right now we are doing the power systems. Okay. So before going further, let's congratulate the students who have scored absolutely well in the ESE examination. As you can see that through our mentorship, we have 5 All India rank under 10, 29 under 50, and 37 under 100. So let's congratulate each one of them and hope next year there will be more students who will score well in the ESE exam, GATE exam, AJ exam, DMRC, HPCL, and many more. Okay. So let's start our today's session. So this is the first question on your screen. So read the question carefully and try to solve it. And again I'm telling you that I have said in my earlier classes that bacho, there are many students who are watching the recorded session, but I will hope that you will come and watch the live session so that so that if you have any doubt you can ask in live. Also it motivates us when the students are watching our live sessions. Okay, so let's try to solve this question. So read the question carefully. We have 4 subconductors are arranged in such a manner that they form the corner of a square. The radius of each subconductor is 1 centimeter and the adjacent distance between the 2 subconductors 50 centimeter. We have to find the self GMD of the subconductor of this configuration is. Now understand this point very carefully. During our calculation of inductance and capacitance, we deal with 3 types of geometric mean. We deal with GMD, we deal with GMR, we deal with the self GMD. Okay, the self GMD, or the particular question they are asking, the self GMD is always calculated in case of a bundled conductor. I hope you have heard about this conductor because the preparation you have already done. Right now we are doing the revision, so we are not going in a depth what is a bundled conductor or what's the advantage and disadvantage of it. Okay. So this particular self GMD we calculate in case of a bundle conductor. Now they are saying we have a 4 subconductors. 4 subconductors means that we have a 1 conductor. Inside that we have a 4 subconductors. No, it means that one phase of a conductor are made up of 4 conductors. Okay. So here we can draw the diagram easily. So since we have a 4 subconductor, wait a sec. Since we have a 4 subconductors, we can draw the diagram like this. We have 4 subconductors. Now distance between each subconductor is given. Let's suppose I'm taking S and the radius is given R. Okay. Now apart from this, what we can do? Can we find out distance between these two? Yes, it is also S. And it is also S. Because they have clearly mentioned that they are arranged in such a manner that they form the corner of a square. Okay, let's suppose it is 1, 2, 3, 4. Okay, the name of a subconductor. Now, how to calculate the self GMD? Whenever you have a symmetrical configuration, for example, in this case, we have a symmetrical configuration. So whenever you have a symmetrical configuration, the self GMD of the entire bundle conductor is equal to GMR of a single conductor. GMR of a single conductor. So you can choose any single conductor here, find its GMR, and that will be the self GMD of the entire bundle conductor. This is very, very important. But if we have a non-symmetrical configuration, for example, the horizontal configuration, then you have to find out the self GMD, or to find out a self GMD, you have to find out the GMR of each and every conductor. That is very important. Okay. So here I can say, what is self GMD? What is self GMD here? It is equal to GMR of any subconductor you can choose. I am choosing the first subconductor. So finding out GMR of that. So what is the GMR of first conductor? The distance of that conductor with itself, distance of that subconductor with the second one, distance of that one with third, distance of one with respect to 4 raised to power 1 by 4. Like this. Now what is the distance of the conductor with itself? That is denoted by the symbol 0.7788 R, है ना, 88 R. Distance of first subconductor with the second is equal to F. Distance of first subconductor to third. Now this is important. First subconductor to third. Here you can see it is formed the diagonal of a square. It is the diagonal of a square. Now what is the formula of a diagonal of a square? It is root 2 multiplied by side. Now distance of first with the 4 is also S. Raised to power 1 by 4, raised to power 1 by 4. So I can write down like this, root 2 multiply 0.7788 multiply by R multiply by S cube raised to power 1 by 4. है ना? Now I can put all the values. So it comes out to be root 2 into 0.7788 multiply. Now what is the radius? Radius is given how much? Radius is given, let me see, wait a sec. Radius is given 1 centimeter and distance is given 50 centimeter. Okay. So radius is given 1 centimeter, distance is given 50 centimeter. Whole cube raised to power 1 by 4. Now we have to use the calculator here. Without that we cannot solve it. Now tell me, who has joined the session? Okay, बच्चे ऑनलाइन हो, एक बार बताओ तो कौन कौन सेशन में आ गया, अदरवाइज मजा कैसे आएगा ऐसे. Into 50 raised to power cube raised to power 1 by 4. So it comes out to be 19.26 centimeter. It comes out to be 19.26 centimeter. Understand this point? Yes or no? So देखो क्वेश्चन में फिर से देखो क्वेश्चन क्या रहा, एक बार let's see the question again. So in the question they are saying that we have a 4 subconductors. Whenever they are talking about a subconductor, whenever they are talking about the self GMD, always remember we have given a bundle conductor. In a bundle conductor, it is very much important to note down that we have a symmetrical configuration. Like this, we have a symmetrical configuration of a subconductor. So when we have a symmetrical configuration, to find out the self GMD of entire conductor, you have to find out the GMR of a single subconductor. So you can choose any subconductor here. For example, 1, 2, 3, 4. I have chosen the first subconductor and find out its GMR. And what is the GMR? GMR is the distance of the particular conductor from itself and the other conductors and the multiplication. And raised to power equal to how many terms we have? 1 by 4. Okay, you know now how to find out geometric mean? Good afternoon, Sonia. You know now how to find out the geometric mean? It's very important, bachcho. One question definitely you can expect from here, either from 1 mark or a 2 mark question. Okay. Now let's do another one. Also, it's a good question. Let's do another one. So read the question carefully. Read the question carefully and try to solve it. Now we have a composite conductor here. Okay, composite conductor means that a single conductor contains a multiple subconductors. For example, ACSR. ACSR is an example of a composite conductor. Okay, you have heard about ACSR very much. It's not an ACSR, but I'm giving you one example of it. Okay, so read the question carefully. A single phase composite conductor system shown in figure the R1 and R2, the radius of each subconductor is given 2 and 1.155. Conductor form forward path. अच्छा, conductor A is a forward path and this form a return path. What is the inductance of a forward path will be? We need to find out inductance of a forward path. Good morning, Arin. We need to find out the inductance of a forward path. ठीक है, forward path का हमें inductance find करना है. यहाँ पे फॉर्मूला क्या होता है inductance का? 2 into 10 raised to power minus 7 ln GMD divided by GMR Henry per meter. This is the formula of inductance. This is the formula of inductance. Very important. ठीक है, अब देखो इसको फाइंड करने के लिए we need to find out GMD and GMR. But read the question carefully. They are saying we need to find out inductance of forward path only. It means the inductance because of the conductor A only. Because of the conductor A only. It means I need to find out GMD and GMR of A only. We don't need to find out GMD for B or GMR for B. Okay? That's why क्वेश्चन को अच्छे से रीड करो. ये काफी इंपॉर्टेंट होता है कि आपसे क्वेश्चन में क्या पूछा गया. अदरवाइज होगा क्या, आपके पास आंसर डिफरेंट आ जाएगा. एंड आई एम प्रीटी मच श्योर कि वो आंसर भी आपका इन ऑप्शन में दिया हुआ होगा. दैट्स व्हाई यू हैव टू रीड द क्वेश्चन वेरी केयरफुली. सो इफ यू टॉक अबाउट द GMR of a conductor A. GMR means that you need to see that conductor only and nothing else. आपको बस वही कंडक्टर देखना है कि उसके अंदर कोई सब कंडक्टर है या नहीं, तब आप उसका GMR फाइंड करोगे. जब भी आप GMR फाइंड करते हो आपको कोई दूसरा कंडक्टर देखने की जरूरत नहीं है. फॉर एग्जांपल यहाँ पर कंडक्टर A है और ये आपके पास कंडक्टर B है. अगर मैं GMR फाइंड कर रहा हूं कंडक्टर A का, तो मैं सिर्फ कंडक्टर A को देखूंगा, B को देखूंगा ही नहीं. तो यहां पर देखो, इनसाइड अ कंडक्टर A वी हैव ओनली अ सिंगल कंडक्टर. सो इन दैट केस व्हाट इज द GMR? दैट इज इक्वल टू R डैश. इट इज 0.7788 मल्टीप्लाई बाय R. 0.7788 मल्टीप्लाई बाय R कितना है यहाँ पे? R1 इज 2 सेंटीमीटर. आई एम कन्वर्टिंग इट इनटू अ मीटर. सो कितना आ गया? कोई भी डाउट हो पूछ लेना, कोई भी डाउट हो पूछ लेना. तो लेट मी सॉल्व इट. So it comes out to be 0.0156 मीटर. ओके, GMR ऑफ कंडक्टर है. नाउ अंडरस्टैंड. नाउ हमें क्या फाइंड करना है? GMD. तो एक बार ध्यान से सुन लो, आपका पूरा समझ में आ जाएगा. जब आप GMD फाइंड करते हो, whenever you are going to find out GMD, no need to see inside that particular conductor. आपको दूसरे कंडक्टर्स को देखना है. जैसे कि हमें GMD फाइंड करना है इसका, हमें इस कंडक्टर का GMD फाइंड करना है, तो मैं यहां से जो दूसरा कंडक्टर है उनका डिस्टेंस देखूंगा, जो दूसरे कंडक्टर है उनका डिस्टेंस देखूंगा. इसके अंदर देखने की जरूरत नहीं है. ठीक है, तो यहां से आपको दिख रहा है कंडक्टर B. नाउ कंडक्टर B के अंदर ही 3 सब कंडक्टर्स हैं. तो इसका डिस्टेंस यहां से, इसका डिस्टेंस यहां से और इसका डिस्टेंस यहां से, ये 3 डिस्टेंस हमें देखने होते हैं. तो ध्यान रखना, GMR GMD में कंफ्यूजन होती है. GMD में आपको कंडक्टर के अंदर नहीं देखना, कंडक्टर के बाहर देखना है आपको. GMR में उसके अंदर देखना है. ठीक है, सिंपल सा कॉन्सेप्ट है. तो यहां पे अगर मैं GMD फाइंड करूं, इफ आई वांट टू फाइंड आउट GMD ऑफ कंडक्टर A, तो क्या होगा? A का डिस्टेंस B1 से, A का डिस्टेंस B2 से, A का डिस्टेंस B3 से, रेज टू पावर 1/3. 1/3 क्यों आया? बिकॉज वेन एवर वी फाइंड आउट अ ज्योमेट्रिक मीन, तो जितने नंबर यहां मल्टीप्लाई करते हो ना, उतनी आपकी 1/, में पावर चली जाती है. याद रखना, दिस इज इंपॉर्टेंट. सो B1, तो A का डिस्टेंस B1 से कितना है? A का डिस्टेंस B1 से कितना है? चलो फाइंड करते हैं. A का डिस्टेंस B1 से, वी नीड टू फाइंड दिस डिस्टेंस. ओके, ये 1 है, ये 2 है, तो मैं बोल सकता हूं इट इज इक्वल टू 2 स्क्वायर प्लस 1 स्क्वायर इक्वल टू √5. वी कैन से इट इज अ √5. A का डिस्टेंस B1 से, अरेंज आंसर दे दिया, वेल डन. A का डिस्टेंस B2 से कितना है? 2. A का डिस्टेंस B3 से कितना होगा? √5. सो वी कैन पुट द वैल्यूज हियर. √5 टू √5 रेज टू पावर 1/3. ओके, तो इसको बस सॉल्व करना है मुझे. We need to solve this. So 5 to the 10. So it comes out to be 2.15. It comes out to be 2.15 meter. So finally inductance कितना होगा? 2 into 10 is to power minus 7 ln 2.15 divided by 0.0156 Henry per meter. यूनिट्स ध्यान रखना, यूनिट्स इंपॉर्टेंट है, यूनिट्स की मिस्टेक नहीं होनी चाहिए। मीनू सर बाय सॉल्विंग इजी क्वेश्चन, बेटा it depends on what's your target, what you want to achieve from the gate examination. Tell me, then I will give the answer for this. Tell me, then I will give the answer for this. What's your aim of giving the gate examination? क्या आपका aim क्या है? What's your aim? So it comes out to be 0.985 millihenry per kilometer. ठीक है? So let me check which option is correct. ऑप्शन बी, ऑप्शन बी। अरे कैलकुलेशन चेक करो बेटा, अरे कैलकुलेशन चेक करो। तो बिनू टेल मी व्हाट्स योर पीएसयू ना बेटा, इफ योर टारगेट इज ऑफ पीएसयू एंड इफ यू आर फ्रॉम अ जनरल कैटेगरी देन you will not going to get anything if you are going to solve only easy questions. Okay, this is the truth, I am telling you bluntly. So if your target is PSU and you are solving only easy question, you are not going to get it if you are from a general category. Even if you are from the reserve category, there is a very less chance if you are going to solve only easy question. Okay, because from an easy question you can let's see, you have attempted all the 1 mark question correctly, and because you are solving an easy question, so I will say only 10% of 2 marks question you have calculated, you have corrected easily, so you will score around 35 and 40 marks, and this is not enough for the PSU. Okay, next one, this question again, next question. One more thing, inductance is more important than capacitance, that's why my focus is on inductance. Otherwise capacitance का formula भी easy होता है, you need to find out GMD and GMR, and from that you can find out the capacitance, right? So the main focus is to find out GMD and GMR. After that you can put it into a formula of inductance and capacitance and you can solve it. Okay, so यहाँ पर GMD GMR find करो, मुझे बताओ क्या होगा। This is a question from a double circuit line. The chances of question coming from a double circuit line is less, but what they can do, they can ask you in 2 marks what is the GMR and GMD in a double circuit line. In this we have to find out both of them, but in exam the high chance that they can ask you only one thing, GMD or GMR. So solve करो क्या होगा। So we have given 6 conductors in a double circuit line. Each conductor has a radius of 12 mm. The 6 conductors are arranged horizontally. Remember, this is asymmetrical configuration. ठीक है, remember this is asymmetrical configuration. The sequence of conductor ABC given है. The inductance per kilometer per phase of the system is. हाँ अरिन, I'm waiting. Don't worry. Just solve it. Find out GMD and GMR. And meanwhile, Binu, tell me, beta, why you want to solve only easy question? Why you want to solve only easy question? If it's easier to solve easy question, then why we are discussing the difficult question here, or anyone if you see the videos? Na? Try to challenge yourself. Because the shortcut path will never help you, whether it's a gate exam or the life. Okay. For example, if you are late in starting a preparation, then don't worry, you can skip this particular year and prepare after that and give the exam in 25. You know, but whenever you are going to give exam, give it your 100% for at least 2 to 3 months. Okay, so first let's talk about GMR. Now when we talk about a GMR, remember, in case of a 3-phase circuit, if it is an asymmetrical configuration, what's the simple formula? GMR of conductor A, GMR of conductor B, GMR of conductor C raised to power 1/3. This you need to understand. You know, but if you have started this month, then why you are worried about? Because the time has already left now. Just started this month, time has already left, because this is your choice to start this month now. But you can do one thing, you can prepare for the 25 examination, and meanwhile there will be many different AJE examination and your PSU examination that you can do. You can solve, you can give those exams also, you know. So if you have started just this month, then there is no worry about 24 examination, you know, because the time has already left. There is only hardly 1.5 month is left. So GMR is how much? DA, DB and DC. Now you have to first find out GMD of each conductor. So what is the GMD of this conductor? GMR, sorry, my fault. What is the GMR of this conductor? It is equal to DA, A dash, D, A A raised to power 1 by 2. Yes or no? Do you understand how I have written this thing? Yes or no? अगर कोई भी डाउट हो पूछ लेना. So D A dash. A से A dash कितना है? 2 2 2 6. We have 6. 0.7788 multiply by how much is the radius? 12 mm. Now distance is in meter. This is mm. So I have to convert it into a meter. So 12 into raised to power 10 minus 3 meter. Okay, raised to power 1 by 2. This comes out to be dA. Now let's solve it. किसी टॉपिक में कोई भी डाउट हो पूछ लेना, ठीक है. So it comes out 0.24 है ना, 0.24 meter. Now let's talk about dB. What is dB here? Again, the distance of B by itself, distance of B by its subconductor, raised to power 1 by 2. So BB is 0.7788. Radius is same, 12 mm. 10 is to power minus 3. And what is the distance of B with B dash? 2 2 2. It's same. 6. It's same. 6. So it comes out to be 0.24 meter again. Now let's talk about DC. The distance is same. Let's check. 2 2 2. The distance is same. The distance is same, right? So it is also comes out to be 0.24 meter. So GMR is how much? GMR is equal to 0.24 raised to power 3 raised to power 1 by 3. It comes out to be 0.24 meter. Simple. 0.24 meter. So tell me, Aryan and Aryan, are you getting this GMR? Yes or no? Are you getting this GMR? And anybody else who are solving this question, are you getting this GMR 0.24 or something else? Now let's talk about GMD. Let's talk about GMD. Now remember this thing very carefully. If in the question it has asked only of, then they are asking inductance na, so you have to find out. Wait a sec. क्या हो गया इसको? हाँ, what you are saying, single phase na beta, that is very important. They are asking a single phase. Remember one thing in this case very carefully. You have to remember one thing. We are talking about the three-phase circuit. In three-phase circuit, you have two conditions possible. Let me tell you this thing. In a three-phase, you have two type of condition that is possible. One is transposed line. One is transposed line, and another one is untransposed line. Another one is untransposed line, and non-transposed भी बोल सकते हो, ठीक है? Untransposed line. When you talk about the transposed line, it is important that inductance per phase is equal to inductance of A, B, and C. But you have to calculate the inductance carefully, like the way we have done here. In case of a transposed line, you have to find out the GMR of each conductor in a single phase, whether it is a phase A, phase B, and phase C, and then you have to solve it. Now in untransposed line, you have inductance per phase is not LA, not equal to LA, not LB, not LC. In that case, you have to find out the inductance of each phase separately. Now understand one point carefully. If the non-transpose word is mentioned in a question, then you have to take a non-transpose. Otherwise, you have to take the transposed case. In this question, there is no mention of transposition, but you have to take by default the transposed case. Because in non-transposed case, what will happen? The complex term will also come. In GATE examination, they never ask question on untransposed, so that is not important for us. Now when you talk about the transposed line, again you have two cases. One is symmetrical configuration, another one is asymmetrical configuration. A symmetrical configuration is like this. This is phase A, phase B, phase C. This is your symmetrical configuration. So in this symmetrical configuration, since the distance is same, so in this symmetrical configuration, you can write it like this, that GMR is equal to GMR of A. That is absolutely correct if you have a symmetrical configuration. Okay, and then you can find out GMD also. But when you have an asymmetrical configuration like this, in this question, you have to write down the GMR in this manner. Because of the values that I have given here, you have a equal DA, DB, DC here, but in examination, they can be different. Okay, that is very important कि आपका symmetrical में क्या हो रहा है और asymmetrical में क्या हो रहा है, ठीक है? That's very important. Now then, when we find out the GMD, in GMD you have to write down all the distances you have. All the distances means the distance of A from B, distance of A from B dash, distance of B from I can say AB dash, okay, distance of B from C, distance of B from C dash, ठीक है. Now next, distance of C from A, distance of C from A dash, distance of B from A, distance of B from A dash. Is there anything left? Is there anything left? Let me check. AB dash, and you have a CA dash, okay, and you have a BA dash, and BC dash, okay. Anything is left here? Okay, yes or no? One thing also left. अगर A का देखोगे, B से B dash ले लिया, but A का ना C से और C dash नहीं लिया आपने, A का A से और C dash नहीं लिया, ठीक है. सेम हियर B से B से ले लिया और CA कंप्लीट हो गया. ऐसे चेक कर लो, A का B ले लिया, A का B dash ले लिया, A का C ले लिया, A का C dash ले लिया, B का C ले लिया, B का C dash, B का A और B का C dash. हाँ, अब कंप्लीट हो गया ना. 1 2 3 4 5 नहीं, एक पेयर और बचा बेटा, एक पेयर और बचा होगा यहाँ पे. A का B हो गया, A का C हो गया, ठीक है. B का C हो गया, C का A हो गया और C का B बचा हुआ. अच्छा, CB एंड CB डैश है ना. रेज टू पावर 1 2 3 4 5 6 7 8 9 10 1 2 3 4 5 6 7 8 9 10 11 12 1 raised to power 12, 1 raised to power 12 है ना. 1 raised to power 12. Now what you can do because many distances are same here. हाँ, वो सेम है, बट लोग है ना, उसकी पावर भी डिक्रीज हो जाएगी. आप देखोगे ना, आपके पास ए बी और बी ए सेम है, ए बी और बी ए सेम है, देयर इज नो वरीज. आप जब पावर लगाओगे कम हो जाएगी. तो ये बस आपको मैं जीएमडी लिखने का मेथड बता रहा हूँ, जीएमडी लिखने का मेथड बता रहा हूँ कि आपको हर एक डिस्टेंस लिखना है. अदरवाइज क्या है, ए बी और बी ए सेम है, आप देखोगे ए बी डैश और बी ए डैश ये भी सेम है, तो पावर आपकी क्या हो जाएगी, हाफ हो जाएगी. ठीक है, तो हर एक कंडक्टर से लिखने का मेथड बता रहा हूँ. अगर आप एक ही बार लिखना चाहो तो वो भी सही है, कोई दिक्कत नहीं उसके अंदर. ठीक है, मतलब अगर आप इसको इस तरीके से लिखो तो कोई प्रॉब्लम नहीं है कि डी ए बी डैश है ना, डी बी सी डैश, हर एक टर्म आपकी एक बार आ जाएगी. डी ए सी डैश. अगर आपको इस तरीके से लिखना है देन देयर इज नो प्रॉब्लम एंड यू कैन राइट इट डाउन इन दिस वे. ओके, तो बस अब क्या करना है, यहाँ पे वैल्यू पुट करनी है. आफ्टर पुटिंग आउट अ वैल्यू, बिकॉज सारी वैल्यूज दे रखी है, आप देखोगे सारी वैल्यूज यहाँ पे दे रखी है, तो आफ्टर पुट द वैल्यूज हियर यू कैन फाइंड आउट द इंडक्टेंस. ठीक है, तो इंडक्टेंस अब आप खुद फाइंड कर लेना, अदरवाइज इट विल कंज्यूम मच अमाउंट ऑफ टाइम. इंडक्टेंस आप खुद फाइंड कर लेना, जीएमडी बाय जीएमआर. बट वन थिंग यू नीड टू अंडरस्टैंड हियर बेटा, जीएमआर इज वेरी इंपॉर्टेंट. जीएमआर थिंग इज वेरी इंपॉर्टेंट टू फाइंड आउट कि कैसे आपको जीएमआर यहाँ पे फाइंड करना है. ठीक है, दिस इज वेरी मच इंपॉर्टेंट. आप सिमेट्रिकल और एसिमेट्रिकल कॉन्फ़िगरेशन का ध्यान रखना. Now before going further, let me give you one information. Then Richa ma'am is going to take a wonderful workshop on the topic, that's the ideal strategy to be a topper in 2025. So if you are an aspirant who is going to give exam in 2025, you can attend this workshop on 20th December at 7:30 p.m. on our app. Also, there is a scholarship test going on which is happening on 24th December. So don't forget to attend this test. In this, you are going to get 90% off on our programs and you can register for it on our app. Okay, bachcho? So don't forget to attend this scholarship test. Now, next one. Now we are going in the ABCD parameter questions. Now, understand one point. You have to remember the ABCD parameter of each and every line. Whether it is a short, medium, long transmission line, you have to remember it because 1 mark question can come directly from there. What is the ABCD parameter of long transmission line pi model, or the medium transmission line pi model? What is the ABCD parameter in a long lossless transmission line? So that you need to remember. Okay, otherwise there are some numericals that they can ask you and that we are going to discuss here. So read the question carefully and find out the charging current here. So we have given a 220 kV 200 km long 3-phase transmission line has the following ABCD parameter. Find the charging current per phase. We need to find out the charging current per phase here. We need to find out the charging current per phase here. Okay, think about it. Agar formula yaad hai, you can use the formula directly. Otherwise, I will tell you it's just the 30 seconds to get the formula. It's just the 30 seconds to get the formula. When you talk about a charging current, always remember that we have an open circuit. We have an open circuit at receiving end. We have an open circuit at receiving end. This is important. it means that IR is 0. It means that IR is 0. We have an open circuit at receiving end. Now we can also take IS is equal to IC, which is the charging current. Now if you know the ABCD parameter, what is the ABCD parameter? That VS is equal to A times of VR plus B times of IR. IS is equal to C times of VR plus D times of IR. So if you put IR equal to 0 and IS equal to IC, so what you will get? Charging current is equal to C times of VR. Charging current is equal to C times of VR. Now what is VR here? Because IR is 0. VR is VS by A. So charging current comes out to be C by A VS. Charging current comes out to be C by A VS. Okay. Now let's see the question. Let's see the question. We have given, we need to find out magnitude only, na? Okay, we will find out only magnitude. So it will be magnitude of C, magnitude of A and VS. Now always remember they are talking about the per phase. But here we have given the line voltage 220 kV. So C is 0.5 into 10 raised to power minus 4 divided by A. What is A here? 0.96. 0.96 multiplied by 220 divided by root 3. Okay, let's solve it. बताओ क्या आंसर आएगा? Solve करो इसको. And also share the session among your friends. बच्चों देख रहा हूँ मैं लाइव आपका कम होता जा रहा है. तो एक बार सॉल्व करके देखना कितना आ रहा है. 6.61 एम्पियर आ रहा है. दिस इज इंटू 10 इज टू पावर 3 भी होगा बिकॉज ये किलो वोल्ट में है. तो एक बार सॉल्व करके देखो कितना आ रहा है. और मैं भी एक बार चेक कर लेता हूँ. 6.61 है ना. इतने क्वेश्चन इतने आ रहा होगा ना. हाँ, तो 6.61 एम्पियर इज द चार्जिंग करंट हियर. And what they are asking, remember this thing that it is a phase voltage. Remember this thing that this is a phase voltage. Don't forget this one. Otherwise, your answer will get wrong. This is the phase voltage. And we have given the line voltage, phase voltage. Yeah. And what is the charging current? Milliampere आ रहा है क्या? Milliampere कैसे आ रहा है बच्चे? Milliampere 220 kV है ना ये. 220 kV है ना ये. तो 220 kV है तो यहाँ पर क्या आएगा? इंटू 10 इज टू पावर 3 आ रहा होगा ना. एक सेकंड, यहाँ पे क्या आ रहा है? इंटू 10 इज टू पावर 3 आ रहा है. तो मिली एम्पियर कैसे आ रहा है बताओ मुझे. 220 kV है ना. 220 10 इज टू पावर 3 ये आपके पास हो गया. मिली केवी कैसे आ रहा है? मिली आ रहा है क्या? एक बार फिर से चेक करना. मिली आ रहा है. ठीक है, एम्पियर में आ रहा है. अब चेक कर लेंगे, कोई दिक्कत नहीं है इसके अंदर. बाकी बताओ कोई मैंने यहाँ पे साइन तो नहीं मिस कर दिया ना. साइन तो मिस नहीं करा. यहाँ पे 0.96 है, यहाँ पे 0.5 इंटू 10 इज टू पावर माइनस 4 है और ये 220 kV है. ठीक है, सही है. नेक्स्ट क्वेश्चन. नेक्स्ट, ये अच्छा क्वेश्चन है. इट्स अ 1 मार्क क्वेश्चन. इट्स अ 1 मार्क क्वेश्चन. मैनी टाइम हैज बीन आस्क्ड दिस वन इन अ 1 मार्क क्वेश्चन. So try to solve this. The ABCD parameter of 220 kV line are given. If the sending end voltage of a line for a load delivered at nominal voltage is 240 kV, find the percentage voltage regulation here. We need to find out the percentage voltage regulation here. Okay. We need to find out the percentage voltage regulation here. And bachcho who are watching the recorded session, I will advise them to watch the live session. Tomorrow we are again going to discuss the question based on surges and a long transmission line. The timing of the class will be 3 p.m. So we are going to discuss the question based on surges, long transmission line and particular cables also. So voltage regulation find करनी है. Now you need to understand one common formula of a voltage regulation. One common formula of voltage regulation is Vs by A minus VR divided by VR. Multiply by 100. This is the common formula of a voltage regulation and it's going to be true for every type of line, whether it is a long, short or a medium transmission line. Now to use this formula you require this. To use this formula you require this magnitude of A, which is actually given here. So you need to find out what is the source voltage and what is the receiving end voltage. So read the question carefully. The ABCD constant of 220 kV line. It means this is the rated voltage. It means this is the rated voltage, and that is going to be a receiving end voltage. This is the rated voltage. Now they are saying if the sending end voltage is 240 kV. Okay. So now put all the values here. 240. A is given 0.96 minus 220 divide by. They have given 220. Divide by 220 multiply by 100. That will give you the voltage regulation 6.38%. Okay, let's see. 6 minus 220 divided by 220. So it gives 6.3. 13.6 आ रहा है. एक बार check करो. 13.6 we are getting. 13.6%. एक बार check करो. कहाँ मिस्टेक करी अरिंद तुमने? एक बार चेक करो. है ना? So it comes out to be 13.6%. Okay. Now understand this thing carefully. This is the general formula of voltage regulation. Is going to be used whether it's a short transmission line, long or medium. One more thing, I'm giving one extra point here, that this value is equal to 1 if you are talking about a short transmission line. If you talk about short transmission line, the value of it is equal to 1. Then the formula is just Vs minus Vr divided by Vr. But here they have given the value of a constant A. So we have to use that particular value, which is 0.94. Okay, next question. Now, before going to next question, let me tell you that we have already launched our mega mock test, which is free for all of you. You just have to register for here, and the registration link is open till 22nd of December. You have to register for it, and you can get the free access to all the mock tests we have. Here you can see the gate syllabus and the particular pattern also. So this particular test will boost up your this particular test will boost up your confidence, and once your confidence boosts up, you can see the particular topics in which you are lagging, and you can prepare for that topics also. सर नॉमिनल नहीं यूज किया बेटा, नॉमिनल यूज करने का यूज नहीं ना, बिकॉज आपके पास सिंपल फॉर्मुला दिया हुआ है. अदरवाइज आप क्या करोगे? अगर आपको वोल्टेज रेगुलेशन फाइंड करना है तो आपको वो बड़ा फॉर्मुला यूज करना पड़ेगा. अब उसके लिए आप सारी वैल्यूज पुट करोगे, उससे भी आंसर आपका सेम आएगा, है ना. बट उसके लिए आपको z और y की वैल्यू फाइंड करनी पड़ेगी. तो सिंपल एक जनरल फॉर्मुला याद रखो, दैट vs अपॉन a माइनस vr डिवाइड बाय vr. उससे होगा क्या? अगर आपको ABCD पैरामीटर गिवन है तो उसका a आप यूज कर लो. अगर इसी को 2 मार्क्स का क्वेश्चन बनाना है तो दे विल प्रोवाइड यू वन पर्टिकुलर नेटवर्क, और वहां पे फिर आपको a पैरामीटर निकालना पड़ेगा. ठीक है. तो जब ABCD पैरामीटर गिवन ही है तो आप क्यों उसके अंदर नॉमिनल में जा रहे हो या फिर उसको एग्जैक्ट इक्विवेलेंट में जा रहे हो? ठीक है. और नॉमिनल हमारा किस में यूज होता है? इट यूज इन अ मीडियम ट्रांसमिशन लाइन, और एग्जैक्ट हमारा कहाँ यूज होता है? इन केस ऑफ अ लॉन्ग ट्रांसमिशन लाइन. ना क्वेश्चन इजी है ये, क्वेश्चन ध्यान से रीड करो. A 50 Hz transmission line is 300 km long and it has total series impedance and the shunt admittance. The receiving end load is 50 megawatt at this and this. Find the sending end power factor in megawatt with short transmission line. With a short transmission line. If you see, this is also a 1 mark question if the paper is difficult. If the paper is easy, then it can also come for 2 mark question. Okay, just you have to use your basic understanding of a short transmission line. They have clearly mentioned here short transmission line approximation. So you have to use the basic understanding here. You have to use the basic understanding. What is the short transmission line approximation? Think about it and tell me short transmission line का approximation क्या होता है? What is the short transmission line approximation? In a short transmission line approximation, remember, we don't use the capacitor. We don't use the capacitor. We only have an impedance. This is the short transmission line approximation. This is the short transmission line approximation. A very, very important formula. Okay. We need to find out the receiving and find the sending end power. Find the sending end power. So can we write down? Sending end power is equal to receiving end power plus losses this formula we can use. Simple a network theory formula कि sending end power is equal to receiving end power plus losses. Now receiving end power is already given in a question. A losses we can write down I square multiplied by R. Whatever the current is flowing here, I, because we are talking about a real power, so we can use I square multiplied by R. Is it correct? Think about it. Is this formula is correct? Yes or no? I square multiplied by R. This is a three-phase line. It's not mentioned, but it is a three-phase line. Since it's a three-phase line, you have to write down 3 times of I square R. You have to write down 3 times of I square R. This mistake a student can do. So remember, in a three-phase line, the total losses is 3 I square R. Now the main point here is to find out the current. The resistance is given is 40 ohm. You have to find out the current here. Now how you can find out current? From this particular knowledge we have. So the receiving end load is 500 megawatt, 220 kV, 0.8 power factor. So we can say current is equal to receiving end root 3 times of voltage multiplied by power factor. है ना? Simple concept. So what is the power here? 50 megawatt. So 50 megawatt है ना? So 50 into 10 raised to power 6 mega root 3 multiply 220 kV and the power factor is 0.8. The power factor is 0.8. Let me check. Power factor is 0.8. Power factor lagging. हाँ. Now we can solve this one. लेकिन लाइन करंट यूज करेंगे तो बेटा लाइन करंट क्यों यूज करोगे? एक बार सोच के बताओ मुझे बच्चे. आप लाइन करंट जो आप यूज करोगे, आपको पता है कि लाइन करंट अगर मैं स्टार फॉर्म में बात करूं, अगर मैं स्टार में बात करूं, स्टार कनेक्शन में बात करूं बच्चे, तो स्टार कनेक्शन में जो आपका लाइन करंट होता है वही तो आपका फेस करंट होता है. लाइन करंट और फेस करंट दोनों सेम होते हैं. पहली बात तो ये बात होगी. दूसरी बात, जो आपको रेसिस्टेंस होता है वो हमेशा पर फेस में होता है. रेसिस्टेंस जो होता है वो हमेशा पर फेस में होता है. कभी भी लाइन रेसिस्टेंस या लाइन इंपीडेंस नाम की चीज नहीं होती है. तो अगर रेसिस्टेंस पर फेस में है तो आप जो लॉस निकालोगे पर फेस का, आप लॉस निकालोगे पर फेस का, वो क्या होगा? फेस करंट होल स्क्वायर मल्टीप्लाई बाय आर होगा. अब अगर आपको 3 फेज का लॉस निकालना है, मतलब आपका टोटल लॉस निकालना है, तो आप इसको क्या करोगे? 3 से मल्टीप्लाई कर दोगे. तो इस तरीके से होता है ना. कभी भी लॉसेस निकालने के लिए लाइन करंट का यूज नहीं होता, क्योंकि ये स्टार कनेक्शन में होती है ट्रांसमिशन लाइन. इसलिए हम बोल देते हैं कि लाइन करंट और फेज करंट सेम है. ठीक है, समझे इस बात को? तो अच्छा, इसको सॉल्व करें. कितना आ रहा है? रूट 3 मल्टीप्लाई बाय 220 मल्टीप्लाई बाय 0.8. ठीक है, 50 डिवाइड बाय आंसर मल्टीप्लाई बाय 1000. So it comes out to be 164.02 ampere. ठीक है, 164.02 ampere. Now we can put all the values in this particular formula. We can put all the values. So sending end power is equal to receiving end पे कितनी power है? Receiving end we have a 50 megawatt. We have a 50 megawatt plus 3 times of 164 whole square. 164 whole square multiply रेसिस्टेंस पर फेज कितना है? इट इज 40 ओम. 40 इंटू 10 रेज़ टू पावर -6. ये क्यों किया है? टू कन्वर्ट इट इनटू अ मेगावाट, बिकॉज जो आपके पास सेंडिंग एंड पावर है वो आपकी मेगावाट के अंदर है. ठीक है, सो लेट्स सॉल्व दिस. तो होल स्क्वायर मल्टीप्लाई बाय 40 मल्टीप्लाई बाय 3 डिवाइड बाय 10 रेज़ टू पावर 6 प्लस 50. तो इट कम्स आउट टू बी 53.23 megawatt. This is the sending end power. This is the sending end power. So in case of power, we can directly apply the concept of this particular concept, that sending end power is receiving end power plus 3 times of I square R. Always remember, this is the per phase losses. I square R is the per phase losses. It is per phase losses. ठीक है? Understood? Correct. एक second. Next one. Now try to solve this one. Read the question carefully. Calculate the distance over with the load is 15 megawatt at power factor of 0.85 can be transmitted by a 3-phase transmission line having the conductor each of radius this much kilometer. The voltage at the receiving end is to be maintained at 132 kV. Then the losses in transmission is 7.5% of the load. So we have to calculate the distance, means we have to calculate the length of a line. You have to calculate the length of a line. तो दिमाग लगाओ, सोचो कैसे सॉल्व होगा. use your mind and think about it, how you can solve this question. And if you know, you can solve, give the answer in comment section also. You can give the answer in the comment section also. So think about it, how you can solve this one. Calculate the distance over which, distance means you have to find out the length of a line. 69.55, Ashwini, very fast bache, 69.55 kilometer. I don't remember the answer, we will find it. But can you briefly tell me how you have solved this question? Can you briefly tell me how you can solve this question? Anyone else try to solve the answer? Anyone else try to solve the answer? What we can do here, simple, I'm giving an idea. We can find out the power loss. It is given, it is 7.5% of the load. So 7.5% of the load, which is 15 megawatt. So this will give me the power loss. Let me calculate. This will give me the power loss. 7.5 into 15 multiplied by 100, 1.13. You know, it will give me 1.13 megawatt as a power loss. Now, if we have a power loss for a three-phase line, we can write down it is 3 times of I phase whole square multiplied by R equal to 1.13. 1.13. So from here, I can find out the total resistance. 1.13 divided by 3 multiplied by I phase whole square multiplied by 10 raised to power 6 because it is in megawatt. So from there, I can find out this total resistance. I can find out this total resistance. If I have a total resistance and also I have a resistance per kilometer, so by dividing both of them, I can find out the actual length of a line. Understood the concept? Yes or no? Understood the whole concept we are doing here? That to find out the total resistance and the per kilometer resistance we have, after dividing both of them, we can find out the length of a line. So let's see. What is the I phase? How we can find out the current? We can use this particular concept. I is equal to receiving end power root 3 times of line voltage multiply root 3 times of line voltage multiply by power factor. है ना? So receiving end power is how much? Receiving end power is wait a sec. Receiving end power is 15 megawatt. So this is 15 divided by root 3 into 132 into how much it is given? 0.85. 0.85. So can you find out a current here? I guess 15 megawatt है ना? So into 10 raised to power 3 because the voltage is in kV. है ना? Understood? जो concept अभी हमने करा ये वाला बात 0.85 है ना? तो 15 divided by answer, so it comes out to be 77.18. 77.18 ampere. है ना? So if it is 77.18 ampere, what is the total resistance? Total resistance is power loss. Total resistance is power loss 1.13. So 1.13 divided by 3 multiplied by 77.18 whole square multiplied by 10 raised to power 6. So इसको solve करते कितना आता है? 1.13 divided by 77.18 whole square है ना into 10 raised to power 6. So it comes out to be 63.23. 63.23 ohms. So what is the length of a line? What is the length of line? So we have a total resistance of 63.23 and we have a resistance per kilometer. Resistance per kilometer is 0.905. It is 0.905. So it comes out to be divided by 0.905. It comes out to be 69.87 kilometer. 69.55. Ashwini said, oh, that's correct. Well done, Ashwini. So it comes out to be 69.87 kilometer. Okay, understood this concept? So we have given a resistance per kilometer. So we have find out the total resistance. Once we have a total resistance, we can divide it by per kilometer resistance, and we can get what is the length of a line. Understood? Now, before moving further, you can download our BYJU'S exam prep app to get access to the free classes also. And one more thing, बच्चों, I have started the free classes on a power electronics. Today I have discussed the question on rectifier. Tomorrow I will discuss the question on inverter at 12 p.m. So don't forget to download the app. And in this app, you can get the particular free access to our classes. Also, there is an option of scores and quizzes there. You can attempt those quizzes and you can see where you stand. So don't forget to download our app. Okay. So before ending a session, I will give you one question in the homework. This is your homework question, and I will expect each one of you to give the answer in a comment section. I will give the heart to the answer which is correct. Okay, so इसको आपको सिंपल क्वेश्चन है, ज़्यादा मुश्किल क्वेश्चन नहीं है. ABCD पैरामीटर दिए हुए हैं, आपको सेंडिंग लाइन एंड का वोल्टेज फाइंड करना है. ठीक है, तो सेंडिंग एंड का वोल्टेज फाइंड करना है और आपके पास सिंपल क्या बोला है, इज अ ट्रांसमिशन लाइन. ठीक है, तो आप ये वाला फॉर्मूला यूज कर सकते हो, VS इज इक्वल टू AVR प्लस BIR. बट इस फॉर्मूले को एकदम अच्छे से यूज करना, एंड वी हैव गिवन एवरी वैल्यूज हियर. नाउ वन थिंग आई नीड टू टेल यू दैट you have to remember the ABCD parameter of each line. I haven't discussed that particular question or that particular concept, but it is important. आपको बस उसे याद करनी है. ठीक है, और इसके रिलेटेड क्वेश्चंस आ सकते हैं. 1 मार्क क्वेश्चन ही आएंगे, 2 मार्क क्वेश्चन जो होते हैं वो आपके इन्हीं पर्टिकुलर कॉन्सेप्ट से आते हैं. अब जो हम कल की क्लास में डिस्कस करेंगे ना, दैट विल बी द सर्जेस एंड अ लॉन्ग ट्रांसमिशन लाइन, और केबल के 1-2 क्वेश्चन हम ले लेंगे. सो कल की क्लास इंपॉर्टेंट होने वाली है. सो डोंट फॉरगेट टू अटेंड टुमारोज क्लास एट 3 PM. वो आपकी 3 बजे होगी, बस आज की क्लास आपकी 1 PM पे थी. ठीक है, तो इसी तरीके से वी विल टेक 4 क्लासेस ऑन पावर सिस्टम इंक्लूडिंग टुडे, और मशीन की 3 क्लास हमने पहले ली थी, तो मशीन की क्लास देख लेना अगर आपने नहीं देखी है. एंड नेक्स्ट वीक वी विल टेक द पावर इलेक्ट्रॉनिक्स लाइक दिस वे. So complete these classes, and also if you have any doubt, you can join my Telegram channel and ask your doubts there. Now before ending a session, you can also avail our Gate 25 and 26 courses, in which we are going to provide you the live classes, recorded lecture, practice quizzes, mock tests, and your whole syllabus will be complete on time. So don't forget to start your preparation with us. Okay, if you have any doubt, you can ask right now. Otherwise, we'll end our session here. Okay. So if you have any doubt, you can ask right now. So I guess क्वेश्चन तो सारे हो चुके हैं, डाउट है नहीं. होमवर्क में वो क्वेश्चन कंप्लीट कर लेना, कमेंट सेक्शन में मुझे उसका आंसर दे देना. सोर्स वोल्टेज फाइंड करना है. ओके, सो बाय गाइस, टेक केयर.